Whoa, the forces of intermolecularness. The UC Davis Chemistry 8A project by Allie Weekly, Emily Wong, and Luke Neo. Whoa. Hope you enjoy.
Hey!
Oh, hey, what's up?
Hey, guys. Hey, you want some grapes?
Yeah,
Sure, I'd love some grapes.
Thank you.
No problem.
Dude, that one's nasty. I'll take this one.
You do that.
Okay.
You know what? I've always wondered how there can be really, really mushy grapes and then really, really hard grapes in the same bag.
Yeah, me too.
Yeah.
It kind of reminds me of intermolecular forces.
What?
No, okay. Hear me out. So, the really, really mushy... No. Just listen.
Okay, I'll hear you out.
The really, really mushy grapes are like van der Waals because they're the weakest forces, so they're not held together as strongly as other grapes, you know? So they're mushy,
I guess.
so you can bite through them easier. They're the easiest to overcome.
Okay.
That makes sense.
Mm-hmm.
Whereas the hydrogen bonding grapes are really, really firm. They're really, really hard. They're the hardest to break through. They're the hardest to get your teeth through because they're hydrogen bonding dipole, and van der Waals. And then like the ones that are in the middle of the road, you know, they're kind of mushy but kind of hard. They're just normal.
Yeah.
That's dipole.
Oh, okay.
Because
That
it's
makes
just,
sense.
You know, it's
All
not
right.
too hard, not too soft.
Yeah.
Just like intermolecular forces.
So, which one is that?
That's definitely dipole.
In the middle? What about you?
Yeah.
That was van der Waals.
Yeah.
Mushy.
Mushy.
I like them firm. Oh, man. I got a firm one. That's hydrogen
I
bonding.
got a hydrogen bonding too.
Yeah. Oh, there we go.
Hydrogen bonding's your favorite type of grape?
Yep.
I
The hard
agree.
ones.
I agree.
They're the hardest to chew.
So I'm going to break it down a little bit more in case my grape analogy didn't work.
Breakdown!
Thank you.
Welcome.
So, intermolecular forces are the connections between stable molecules and atoms. And though these molecules are stable, the forces between them are unstable. And this is due to a brief unequal dispersal of charges. Now there are three main types of intermolecular forces. We have van der Waals, we have dipole, and we have hydrogen bonding. Van der Waals forces, they're also called induced dipole, by the way, little fact for you. These are the weakest of the intermolecular forces, which means they're the easiest to overcome.
Yeah.
The second type of intermolecular forces are dipole interactions. And this type of connection occurs between two molecules, and they occur because the positive end of one molecule comes up next to the negative end of another molecule. These dipole interactions are stronger than van der Waals, but not as strong as hydrogen bonding. It's stronger than van der Waals because it has van der Waals forces alone, and then it has dipole in addition to that. The third type of intermolecular forces are hydrogen bonding. These bonds occur between a hydrogen and an oxygen, a hydrogen and a nitrogen, or a hydrogen and a fluoride. Hydrogen bonds are a type of dipole interaction, and they're the strongest force because they have hydrogen bonding, dipole interactions, and van der Waals forces. Hydrogen bonds are formed between alcohols, OH, and amines, NH, but they're stronger between the alcohols since oxygen is more electronegative than nitrogen.
Woo! So thank you, Allie, for that breakdown of intermolecular forces.
Welcome.
Yep. So I'm going to go ahead and connect these intermolecular forces, this concept that we're doing right here, with my major, which is viticulture and enology. So everyone knows that the main process in winemaking is fermentation. And when a grape undergoes fermentation, it needs to go through two steps. It needs to go through glycolysis and then the actual fermentation itself. So, step one. Thank you. We start with this bad boy right here, glucose. So this is present in the grape juice when it's picked off the vine and then mushed and crushed and all that stuff. And as you can see, you got these little OH guys right there, there, and then one more up there. And if you remember from Allie's discussion about it, the OH is a sign of a hydrogen bond. So glucose undergoes glycolysis, in which these are cut. Lysis. Cut. So the OH is cut, and all those OHs are cut, and then next comes pyruvate. So as you can see, there's no more OHs left. There's a bunch of O's, there's 2 H's, but there's no OHs. Yeah, this is the final product of glycolysis, and you actually have 2 of these. So after you have your pyruvate, it's time to undergo the fermentation process. And we get this bad boy right here, acetaldehyde. So from this, as you can see, CO2 is taken out of the pyruvates to get acetaldehyde. And then after acetaldehyde, that ferments, and we get ethanol. So ethanol is right there. And as you can see, there's actually a hydrogen bond right there. So we made a hydrogen bond. And yeah, there's a bunch of van der Waals forces in these, and the HC bonds, and then yeah. So basically, that's fermentation. Oh man, all this talk about viticulture got me thirsty. I wish I had some wine. That looks good. Oh, okay. It's good. It's a good year.
Luke,
Oh, hey, what's up, Emily?
did you know that when we drink alcohol, our bodies need to break it down by means of metabolism?
Really?
Yeah.
Hey, and that relates to our majors
Exercise bio.
and animal science.
Oh, what a coincidence. Well, hey, I don't really want to stick around for this conversation, so tell these people watching what you got to say, and I'm going to go have some more wine.
Cool.
Peace.
Alright, so this process occurs in one's liver with ethanol. Alcohol dehydrogenase, or ADH, breaks down the ethanol to form acetaldehyde. To do this, it must break the van der Waals forces located in one of the carbon-hydrogen bonds. So one of the hydrogen goes away. It must also break the hydrogen bond located in the oxygen-hydrogen bond right here. So the other H goes away to form acetaldehyde. From here, acetaldehyde dehydrogenase acts to break away another van der Waals force and removes another H from the carbon-hydrogen bond, like this, and replacing it with an oxygen to form acetate. The metabolism of ethanol is basically a reverse fermentation, as what Luke explained earlier.
Alright guys, thanks for watching our video about intermolecular forces.
Even though it's kind of boring.
A little boring, but hey, it's education. Deal with it. So, yeah, thank you, Professor Franz, for giving us this opportunity to make this YouTube video.
See you next quarter.
Yep.
Oh, and if you're wondering where Allie went, she went to go get more hydrogen bonding grapes.
The best ones. The hard ones.